So as a very short recap, in the last video we talked about what AI and what AI is, what is general AI, what is narrow AI. We looked at how we should focus, or rather how we are going to focus only on narrow AI for this workshop. We then look at the different four categories of narrow AI, and we sort of decided that we're going to look into just that of the acting rationally. So in terms of acting rationally, it is a rational agent that acts according to what is the best rational outcome, or where there's uncertainty, the best expected outcome. So now we're going to look at one of the main algorithms in this class of acting rationally, which is in machine learning. So for our next notebook, we're going to be talking about machine learning and also what are the different categories in machine learning. So once again, as a recap, we talked about AI, what AI is. We have the two classes of AI, which is narrow and general. We zoom into narrow. We have the four classes in narrow AI, and we are only looking at the category of acting rationally. And within the category for acting rationally, we have that of machine learning. And in this workbook, we'll be talking about these three categories within machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. By the end of this workbook, you should be able to describe and distinguish the different types of machine learning, which is these three. So maybe you can go to a very simple definition of what machine learning is by Wikipedia. So there are four elements to the definition. We have first the algorithms, we have the statistical models, we have a specific task, and you also have patterns and inferences. So it is the study of algorithms, the models, to do a task without explicit instructions but relying on patterns, inferences, or data instead. We are going to use the running example. In this running example, we are having three variables A, B, and C. A and B are inputs, R is an output. We have four definitions. In the first definition is that of an algorithm. Algorithm is basically just a process or rules to be followed, especially by a computer. In this running example, the algorithm can be a way to find out what is the relationship between A, B, and R. So algorithm will be the way to find out the relationship between A, B, and R. Notice the stress is on the way to find out the relationship. It is not the relationship between A, B, and R, but the way to find out the relationship between A, B, and R. Why? Because the relationship between A, B, and R will be known as the model. So the model will be the relationship between A, B, and R. So for example, we have A times B equals to R. So A times B equals to R is the model between, or rather the model which is the relationship between input variables A, B, and output variable R, and the algorithm is the way to find out what is the relationship between A, B, and R. So there's a very, very subtle difference, but there's a very, very strong difference between the algorithms and the actual model. Then you have the tasks. So the task is what the model in fact does. So for example, you have different tasks in machine learning. So we have, if you want to say you want to categorize numbers, rather objects in images, that is a form of classification. Or if you want to predict something like the house prices in a certain area, and that will then be a regression. So some of the other tasks involve playing a game or solving a certain pattern. So lastly, we have that of patterns or inferences. So the question then becomes, what then defines what is a pattern or what is an inference? So for example, you have the image over here, which is the number 8. If I want to have a classification task, which is to determine if the image shows the number 8, one of the approach may be this: scan the top of the image and determine if a circle is present, scan the bottom of the image and determine if a circle is present as well in the bottom image. And if we find circles in both the top part of the image and in the bottom part of the image, we say that, oh, then we think that the image is number 8. So what do you think about this algorithm? So I give you some time to think about this. So obviously this is not the best algorithm that you can think of. So for example, what happens if you just have two circles, one at the top, one at the bottom, that are not joined to one another? I mean, they may just be two circles, and it is really the rules that we present are in fact really stringent. And in fact, for the number 8, it may not be total circles as well. How then do you determine if a circle is present? So this to a human looks very much like the number 8, but there isn't a circle at the top, or you can neither say that there's one at the bottom as well. So there are a lot of this has many stringent rules which may not work really well in general. And if you were to so-called scale this out, this is a screenshot I got from googling the number 8 on Google Images, and you can find that the number 8, it appears in all different various shapes and forms. However, to a human being, we can all see that these are all the number 8. But to a computer, if you were to use this naive algorithm, you probably won't be able to get the accurate result. So then these are the 4 different so-called points in machine learning. We are able to get this number 8 in today, or rather we are able to train a machine to recognize this number 8 through relying on pattern and the inferences through a lot of data. So it is when we have a wide range of data that's available, and we train the machine with this wide range of differing data of the same number 8, then we're able to get a good so-called understanding for the machine as to what defines this number. So we'll go more into this as we get along this workshop. But let's go back to our main focus, which is the different categories of machine learning today. So there are 3 main categories of machine learning today, and that will be supervised learning, unsupervised learning, and reinforcement learning. So this will be made clearer through a few examples, which we'll go through now. So for supervised learning, we learn the model through example. So it means that we are teaching the model through a technique known as supervision. So you normally structure your data like an Excel table, and there's a target label we wish to train the model, or rather the data, towards. So as an example, it's like how should you go to school every day, or how do you go to work every day? So it actually depends on a few variables, so which we call them as features. So a variable or feature is like if it is raining, if you have overslept, if the train broke down, or if there's an important meeting. So you either take the bus or the train to school. So assuming that you're diligent and you note down every single time you go to school, and you note down all the different features that you are able to observe as well. So you have the different roles in this table. Every single role is known as an observation, because you observe on that particular instance that there's a rain, that it's raining, that you did not oversleep, that the train did not break down, and you did not have the important meeting on that day. And because of these variables or features, you decided to take the bus. And these goes on for the different roles or the different observations. Every single role is a time whereby you observe a certain state for the different variables or the features, and you decided then to take either the bus or the train. This last row, or this last column is known as the target variable, or what we also commonly call the y variable. These other variables, they're known as the x variables. So these are the variables that are independent. This is the variable that is dependent. And why it is actually quite intuitive. This is dependent because it depends on all the different variables over here. And depending on how these variables, the state of these different variables, the dependent variable will then take the state of either a bus or a train. All the other variables here, they're known as independent, and the reason is also intuitively because they're meant to be independent from one another, meaning that whether it's raining or not should not be affected if did I oversleep, or did the train break down, or was there an important meeting or not. So this is then the difference between the dependent variable, independent variable, the y variable, and the x variable, and this is also known as the target variable. Notice another thing. So in this table, the target variables, they are either the bus or train. This is in particular a kind of supervised learning known as classification. So there are different classes in the target variable that it can take, and it can only take these various classes. So if you compare with the table below, this is a similar table, but instead of classifying whether is it a bus or a train, we're going to say how long it will take me to get to work or the school. So in this example, I'm predicting not a class label, but I'm actually predicting a number. And when I'm predicting a number, this class of supervised learning is known as a regression. So as a recap again, we talk about machine learning for this workbook, and in machine learning we are looking at supervised learning in the first section. In the first section we talk about two things, which is classification and regression. Okay, now let's look at the second class of machine learning algorithms, which is supervised learning. So in supervised learning, we learn the model through data, meaning that we do not explicitly tell the data how we want it to be arranged, but based on how the data inherently is, it tries to find unique patterns within the data to organize themselves. So this graph that you've seen is taken from one of the very popular machine learning packages They call it scikit-learn, sklearn. And on the columns, you will see the different, they call them clustering algorithms. So different clustering algorithms will have different ways of organizing the data. So this is a great example of seeing how different algorithms, they will perceive data very differently. Let's look at just the first row. As a person, you will see immediately that there is two classes of data you can find. One is that of the inner circle, and the other is that of the outer circle. So for human, intuitively, it is very clear that these should be the two classes of data that you will find. We find that some clustering algorithms, they are able to differentiate them really well. So for example, this, and this, they're able to find these two classes in a pretty well and good manner. However, if you compare with this, even this, and this two, you notice that the way they split up the data is not as intuitive as you probably would like. Let's just look at this example. K-means, this is the name of this algorithm is a K-means clustering algorithm, meaning that it tries to find the mean between, or rather it tries to find the centroid of the data points within your data sources. So in this so-called data set, you will probably, if you run the K-means algorithm, you probably will end up with a centroid over here and a centroid over here. So these 2 points are the center of the points in your data set. If this happens, then naturally you will split up your data into 2 halves. This class of algorithms for K-means, it is very useful if you have data that looks like this, or this, and this. It is able to split them up really, really well, because you find that, they are able to find the concentric centroid data points in your data sources really well. But when it comes to data that is joined together, and is very clear that because of the proximity between the points, they should belong to the same cluster, they don't behave as well. Compare with, let's say, dbScan. dbScan takes into account the difference, or rather the distances between the points in your data sources. And so for dbScan, you're able to find out that these points, they are relatively further away from these points, and so immediately it is able to create 2 distinct and unique clusters of points for your dbScan algorithm. If you contrast, this is also doing so this doesn't do as well. If you contrast this with that of the K-means, you'll find that K-means are able to at least find 3 general centroids within this data source. But if you look at dbScan, because of the proximity between these 2 so-called clusters of points, you'll find that they get joined together, unfortunately, because they do belong to the proximity between them are actually pretty near together. So and in cases like this, then this algorithm would definitely not work as well. So this graph in general provides a very extremely good way to visualize what should be the right so-called, or rather also to estimate what should be the right algorithm to apply on your particular data source. And now for the last class will be that of reinforcement learning, where the model actually learns by experience. I think this will be best explained by this video over here. We'll go on to it right now. So we'll be going through reinforcement learning with this video on YouTube. It's not mine, it's actually by 2-minute papers, and this is on Google DeepMind's algorithm, and they ran it using the Atari breakout. So they trained this pedal using the different pixels as input. After 10 minutes, it couldn't really play. After 120 minutes of training, it actually could play pretty well. It's able to remove the blocks on the screen. But after 120 minutes, 240 minutes, is when it realizes that digging a hole in this wall is in fact the best strategy. So it tries to build a hole there, and then thereafter it then clears the screen itself. So we talk about the 3 classes in machine learning. So we have the supervised learning, the unsupervised learning, and the reinforcement learning. So these are the specific tasks. So for machine learning, you will have supervised learning, you either do classification or regression. Unsupervised learning, probably you usually do clustering. Reinforcement learning, there are certain tasks that you would need to carry out. So in the Pong example we have here, the task would then be either to move left, to move right, or to stay put. So these will be the 3 tasks for that the agent is able to carry out for reinforcement learning in this example. So let's look at this this image over here. It is the source is from this location over here. So if I want to say, I want to classify if what kind of fish each of these so-called images is, what kind of task do you think that is? That will be that of a classification task. If I want to predict what is the length of the fish, it will then be a regression task. Okay, so this will be a very simple way to understand for supervised learning what is the difference between classification and regression. For the remainder of this workshop, we'll be focusing only on supervised learning. Okay. So as a recap, we talked about AI, general AI, narrow AI. We zoom into narrow AI. We have the 4 classes of narrow AI. We talked about the rational agents, and within the rational agent, we look at machine learning. In machine learning, we have supervised learning, unsupervised learning, and reinforcement learning. And for the remainder of the workshop, we are only going to focus on supervised learning.